Good afternoon in the graveyard session. Harvest maturity is, I see many familiar faces who actually know exactly what harvest maturity is, and yet even in our commercial industry as it is, it's often one of those things that we get wrong somehow due to, we can see it in defects. So that's quite important that we actually look at harvest maturity. Okay, what are the common characteristics of any fruit and vegetable? Or any ornamentals that are harvested? They are all alive, and we harvest them, so we remove them from the mother plant. They have this little package that they need to survive with for the rest of that journey. And what the intended use is depends on how long that journey will be and when we harvest. So the changes during fruit ripening, we are looking at fruit ripening since maturity is ripening. There are three critical changes. Now, you know when you go and eat a fruit, the first thing you look at, or maybe experience, or maybe the second thing, I should have put color maybe first, but texture. The texture, the firmness, we all know that firmness decreases as a crop matures. Then the second one is color. We buy with our eyes. And one of those things that is predetermined even in our brains is when you go and buy something, you generally don't buy yellow crop. Say, for instance, herbs or veg. You don't buy yellow crop. Your mind is already processed that is more mature compared to a more greener crop. Then the taste. Taste can mean sugars, acids, and the ratio. Phenolics, is it bitter or not? And the aromatics, how does it, certain cultivars just have a really nice flavor. So how does this all fit in with harvest maturity? When one looks at the stage of development, when we harvest it actually plays a big part in that fruit's characteristics, the things I mentioned now. Now, as you can see, a crop has a respiration rate. Now, what is a respiration rate? It breathes. A crop breathes just like us. When you take it off the mother plant, that's a huge stress, and so it respires a lot. While it's growing, it's respiring a lot because it needs energy, ATP, to be able to grow. Now, these growth stages are all on the board here. The first one is CO2 production. That's what we measure the respiration. And respiration just means using up or burning the reserves up. And then you get active growth, development, ripening, and then the senescence part. Now, when we harvest, for instance, something like cocktail maize or fully grown maize, we would generally harvest it during the growth phase or during the fully grown phase. If we harvest dormant bulbs, they are or storage organs. Their development has been completed, but they haven't. Their respiration rate is relatively low and dormant, and that's when we eat them. When we look at deciduous fruit, however, we normally harvest them prior to when we eat them. That's why I said it depends on the intended market. What do you want to do with it? Now, in the deciduous fruit industry, normally we store things, we harvest them before they are ripe, because otherwise they will lose quality, and we will look at those things later on. So we harvest them before the respiration rate goes higher. Other vegetables, for instance, asparagus, we harvest at a high respiration rate because they're still growing. Then the horticultural maturity for deciduous fruit, that is the time when a product is actually ripe. That's when the consumer eats it. When we harvest there, the quality will not be as such that we can handle that fruit anymore. And therefore, we harvest at a physiologically mature stage. Should our product, however, not be physiologically mature, it will not ever reach horticultural maturity, and that's when we harvest too early. So there are these two things to keep in mind as we go along. Now, there's that little package of energy hanging there, and we are going to harvest it and look at how do I decide whether it's ready to harvest or not. Now, one of the first things we look at in pome fruit, apples and pears, are starch conversion. Now, that little package has got starch, which is a sugar basically in a helix form, and that's its carbohydrate reserve or its sugar reserve on which it lives for respiration, for it to be able to survive. Now, how do we measure at what stage it's been broken down? Now, interestingly enough, somebody, I don't know if you remember your biology lectures at school, you have iodine and you painted maybe a piece of bread or a potato and it turned black. Now, we use that same principle in pome fruit. Basically, what happens is you've got this helix of glucose, you've got iodine, and those iodine molecules get trapped in between these helix. If there are more than 36 of those helixes, the apple turns black. If there are less than 36 of those helixes, the apple remains, it goes white. And we have a specific conversion chart, a starch conversion chart. This one we use in the industry, and one can see where the light-colored part is, we call starch breakdown, and one can see 5% means that only 5% is broken down, starch is broken down. And for instance, 20% means that the white part is about 20%. Should it be 80% or over there? That means almost all the starch is gone. That product basically doesn't have any reserves to keep it going for the rest of its storage life. So we generally, in apples, we harvest between 15 to 20, and there are maximum standards in certain cultivars. For instance, in Crips Pink, one shouldn't go above 30 to 40. Otherwise, we get certain types of browning, storage disorders, which are directly related to the amount of starch. Okay, the next thing we look at is total soluble solids. Now, again, many of you have done this before. We get two types of equipment that we measured with, both refractometers. This one is a handheld one. It's very robust. It's quite difficult to break. Really nice to use in an orchard, and I'm sure a lot of you own one. Basically, there's a prism. In that, there's a little glass there, and that's a prism. And a prism refracts light. Now, basically what we do is we put a little bit of fruit juice on that prism, and it refracts the light differently if you put, for instance, a little bit of juice on there, and it gives you a different reading. So you close the hatch, the light goes through, and you get a reading. So in that case, it would be 16.8% bricks. There's also an electronic refractometer, because you can see there's a little bit of judgment needed in between those small figures. So a lot of people like to use the electronic refractometer. It's slightly more expensive and it's not as robust, although they are pretty robust nowadays. Important with both of them that they need to be calibrated. How do we calibrate it? We take distilled water, we put it on this little window, we clean the window, and then we put in more distilled water. You press the 0 button so it measures water at 0. Remember, a sugar solution has a certain consistency, and water a certain refraction, which would be higher than that of water. So water should always be 0. So after that, you go and put a little bit of juice sample there. You can see the light is on there, so it's the same principle. It uses exactly the same principle as a prism. It has a light which refracts and then decides what the real reading is. And in this case, it was 16.2. This was, by the way, the same apple, so that I used for measuring with the handheld. And so calibration is incredibly important. Examples where we use this, all the standards, doesn't matter whether it's apple, pears, plums, all have a certain TSS level they need to be at before they can be marketed. Different markets have different minimum standards. For instance, for Letitia and Songold, you can't market them if they're lower than 11% TSS. Pink Lady, for instance, needs to be higher than 13%. The female Farrell, the Farrell that's really firm when they're eaten, should have a high sugar content. Otherwise, they don't taste nice. So that's why it is important. Another thing, one of probably the first things little children learn, that when they harvest a fruit and it is sour, it's not ready to eat. Hence, we measure also the titratable acidity or acidity. Now, different products are made out of a lot of kinds of acids, not only malic acid or tartaric acid, but over time one measures how they decrease over time. And the one that decreases most consistently with ripening is measured. And interesting enough, in apples and pears, apple acid or malic acid is used as a ripening indice. Now, it's not necessarily a ripening indice because it can change, a lot of factors can influence it. For instance, soil type. Sandy soils generally have lower titratable acidity than more clayey soils. So it's not necessarily a ripening indice per se, but when you start, it will always decrease as you harvest it. So it will be higher in immature fruit, and it decreases generally with ripening. And if it's too low, for instance, our Packham's Triumph sometimes have a very low acidity in certain years, and then our fruit tastes insipid, watery, because the sugar-acid ratio is not there. Okay, so it gives us an indication of quality, but it also gives the post-harvest technologist an idea of whether that fruit would store well. Acidity is what is used in your Krebs cycle. Now, your Krebs cycle is that machine making energy, breaking down that starch. Now, if you have 0 acids to drive that respiration rate, we can't store for very long. So it kind of gives you an indication of how much energy or how many reserves are there to store for a longer period of time. Okay, then seed color. At harvest, we know that, especially in apples, seed color changes from light color to a dark color, and depending on the cultivar, there are certain standards at which you can harvest them. So the riper fruit are dark, like you can see there. These are very ripe fruit. Those are the ones we normally buy in the shop, so most of us have always seen those. We must note that in certain fruit, we've got parthenocarpic seeds. Now, parthenocarpic seeds are those seeds that didn't fully develop. They're always black and flat. We don't use those for maturity indexing, as they don't really indicate maturity. Now, we have a seed color chart, and it's very simple to use. So those fruit would go at a number 6. The color chart has been generated on a computer. Now, in real life, actually the seeds turn a color a lot more defined. So in the standards, one would see a third or a half of the seed is black and the other half is white. And certain cultivars really turn like that. So one needs to, again, go back to the standards to see exactly what they should be. Okay, background color. Who can tell me what is the background color here? Alton, do you want to tell me what the background color is? No. Yeah. The blush. Not. The background color, what gives us an indication of ripening? The red color or the green color? The green color. And that's generally what's behind the red color. The red color is actually on top of the green color, which is formed a little bit later. So we call it the background color. Now, the background color is what tells us whether something is ripe or not in apples. In other cultivars, like, for instance, plums, it's different. Okay, so we call in apples and pears the green color the background color, which changes over time. So we use a simple color chart to show the different hue angles, or actually green color to yellow color. We put fruit behind it, and we decide what color it is. This one is obviously very, very ripe. Generally, we harvest at about 2.5, between 2 and 2.5, not green, not more yellow than number 3. Green color is incredibly important when we export to Africa and to all the other countries. Actually, that's probably one of the first things in ripening changing, before your firmness, before anything else, your green color changes. In certain seasons, it changes a lot quicker than others. So at harvest, that is incredibly important to look at your color at that point in time. So just to show you also an example of plums, how they change color. Even though in Songold they are green, they actually change to a yellow and then eventually to kind of a red. And that in their minimum standard, on the worst coloured side, it needs to be a 4. Whereas, for instance, in Letitia, you have to have they have a maximum and a minimum, and the minimum would be 9 on both sides, or the maximum 13 on both sides. So each cultivar obviously has its own colour chart and its own standards. And also, uniformity is incredibly important with plums. We'll touch on that a little bit later. Firmness. When one looks at firmness, it's measured with a penetrometer. Basically, we peel off a 1 millimeter off the peel on both sides. You can see here, the red side is the sunny side, and the green side is the side that didn't get a lot of sun. So, and one always has to take 2 firmnesses because they generally differ. Generally, the sunny side is a little bit firmer than the shady side. So it's important to take an average. What is also important to note is that the 7.9 millimeter, the thinner tip, is used for pears. Now, if one thinks of a ripe pear, it actually goes quite soft. But when you harvest a pear, it's incredibly firm. And if we would use a thicker point there, it would go right around. So, yeah, so that's why it has got a thinner point. Plums and apples generally are easier to penetrate, and therefore they've got a thicker point. There you can see an apple, and just to show how we peel it on both sides. And this is the 11.1 millimeter point. Now, how to take a firmness reading is quite important. Generally, one goes out to the field with one of these, but how you press it into the fruit makes quite a big difference with the firmness. So it needs to be perpendicular to your fruit as you put it in, and one mustn't do it quickly. It must be at a kind of slow rate, and then one has to only put it into that tip, to that line. Otherwise, you will get an incorrect reading. So that is incredibly important. To kind of stabilize the penetrometer and to make it easier to read exactly the same value or have the conditions the same all the time, one can have put it on one of these, a jaw stand, which one can get at any hardware store, and it's very, very easy to set up to have a more consistent reading and more accurate reading with that. Then in most maturity indexing labs, it's automated. The speed at which it goes in is automated, so we don't make any mistakes. And this is also calibrated, very importantly. Fruit diameter. Fruit diameter doesn't really tell us much about fruit maturity, but it is true that the longer you hang your fruit, the larger they will get. I just put this in because all standards have a certain fruit size, which probably is more an effect of thinning and those things, but fruit size is very important to take note of. So if one looks at the maturity indices that one would typically use in pome fruit, I added grapes there, although they're not really part of the pome fruit. For apples, starch, seed color, background color, firmness. For pear, again, firmness, TSS, starch, seed color, background color, and pecking ease. And the seeds are less important there depending on the cultivar. For apples, starch is incredibly important and firmness is incredibly important. Plum, TSS, color, the uniformity is very, very important. Firmness and mass and diameter. For peach, color and firmness. For apricots, the color and the stone attachment. And for grapes, which sugar and acid ratio is very important because there's no other way of measuring that. I just want to show you this picture on the side here, that uniformity in a carton is very, very important. Sometimes when stone fruit are still green, you can't see at what maturity they are. So one has to have quite a good eye in picking out or through picking. Otherwise, if you strip pick, that kind of uniformity during ripening, you will pick up and you get claims on that. So also something which not a lot of people do, or maybe they do that, is to also look at the inside and the outside of the canopy. And research that we've done with Pink Lady, even with Pharrell, the inside and outside canopy fruit maturity differs vastly. So when one through picks, it's very, very important that one waits, if one leaves green fruit on the tree, that one knows exactly where they are at from a maturity point of view, so that one doesn't go and long-term store them or what have you, do something with them that is not fit for that maturity. Otherwise, they will not last. So taking the variability within the tree in consideration and through picking is very, very important. Okay, so how does maturity indexing work? Generally, there's a sample. Every week you take a sample, plus minus 4 weeks before you anticipate harvest, and people already kind of know, look at other cultivars to see whether it's a fast season or not, so you don't miss it completely. And each orchard must have a minimum of 20 fruit, and if you see the orchard is variable, because sometimes it's on a slope, one can have more samples to take that into consideration. Generally, the sample is taken at shoulder height on both sides of the tree to take the sides of the tree into consideration. And if one can, do inside and outside maturity to have an idea of where they are at. And then you do maturity indexing. Then one goes and compares that to a long-term average. The industry has a database, a long-term database from all the year's data, where they look at where fruit was at a certain time to get good quality, eating quality after storage. And so that the area release has been calculated from that. So when were they physiologically mature? When is the best time to harvest? And HORTIC basically has that database at the moment, and they do that for HORTGRO as a service, but they also do private or commercial sampling of orchards. Then basically what one needs to do is you need to plot all your years that you have up to date. Say, for instance, in this case, it was starch conversion, and there you look at the long-term average, the blue line. And this was 2002, 2003 seasons, so there they started already and they look quite similar. But when you go to week 5, we can see that the 2003 season was slightly below the release criteria and slightly below the 2002. And so you build up your data, your own database for that orchard. And after a while, you will really get to know your orchard. Also with what type of defects you can expect. Then this is just the same, just for firmness. And here you look at the long-term average over there. And 2002, you can see, and 2003, one can see here with the firmness that it's a slightly firmer. So again, it's important to look at the whole picture, not only firmness, not only starch, but look at the whole picture to get an idea. This was for plums, and here we can clearly see that for the days after full bloom, the 2003 season was harvested a lot later. So keeping track of your orchard, knowing your orchard well, is a very good practice for having the optimum maturity. You did all that effort to bring your fruit up to a certain quality, and harvesting at the right time just keeps your fruit till market, till you can sell it. Remember, storage is never a hospital, so when you harvest it, that is the quality you are going to have. So harvesting too late, that wastes a lot of your quality. Okay, so what can we expect? What are the consequences of incorrect harvesting? Now, there are so many things I can mention here. I just mentioned a few. I remember in one season we had a lot of shriveling of fruit that was harvested pre-optimum, and they weren't ready to ripen, and they never ripen. They stay firm. Often farmers are under a lot of pressure to be first in the market, and then they kind of end up with claims because their fruit doesn't ripen. Also, the cuticle needs to develop properly before harvesting can take place, and especially packums could get a lot of shriveling if they're harvested prematurely. Mealiness, my favorite topic of Pharrell. If one harvests post-optimum, and in my book, I know the standards say they're lower, but in my book, if you harvest lower than 6 kilograms, you have a higher risk of getting mealiness, especially when you store for shorter periods of time. If you store long-term, you shouldn't have a problem. So that is kind of a given, and any research that's been done over many years, one can go track that, and that is kind of a fact. Superficial scald, a very hot topic at the moment. Because we can't use DPA anymore, or in most instances we don't use it because we export in most cases. Pre-optimum harvest, all fruit are susceptible to a degree, but if you harvest at pre-optimum maturity, you will get high levels of superficial scald. And it is seasonal, but it's almost like a fact. If you harvest pre-optimum, granny's pre-optimum, you will get high levels of scald. Then there are a lot of other ones that I just want to highlight. For instance, bitter pit is related to a lot of factors. But again, if you harvest pre-optimum, again, your chances are that you will get bitter pit. Your risk is just very high if you harvest pre-optimally. Internal browning of plums. The browning is a storage-related defect, but again, if one harvests too early, the chances are good that you are going to have internal browning. Then woolliness of peach. If you harvest too early, again, it's a storage defect. Certain enzymes that make that the pectins break down properly during ripen, they get inhibited and they ripen all mealy. Now, this is also cultivar dependent and a lot of other factors dependent, but pre-optimum harvest does make that the ethylene is lower and therefore the ripening can't happen. And post-optimum harvest maturity, obviously one of the biggest factors or claims that one always gets are yellowing. And in some seasons it's kind of unpredictable. Some seasons yellow quicker than others, but yellowing is still a very big problem. Then just over-maturity. We know in stone fruit over-maturity can be a very big problem. Diffuse browning, another one of my favorite topics. It's interesting, in South Africa, diffuse browning is the major type of browning, and if you harvest post-optimum, your chances of getting it during long-term storage is very, very good. And post-optimum, in my book, is anything after 30 to 40% starch breakdown, and I know we wait a lot of the time for colour to develop, and we harvest a lot later than that. So if the risk is high, rather don't store for too long. Late water core, we've had a lot of late water core this year. Again, if one stores late water core long-term in over-mature fruit, one will get browning eventually. And those are the few I mentioned here. But there are lots out there. So if one can keep an eye on the standards, they change every year. We try and revise them for DAF. And keep an eye on every cultivar, their recommendations for that season. Thank you very much.